All right. The exponent rule that we're going to talk about in this video is the product rule. All right, so let's look at this first problem. First of all, the product of any problem is the answer to a multiplication problem. So since this is a multiplication problem, this is called the product rule since it's a multiplication problem. I am first going to show you what this problem looks like in expanded form. So x to the fourth, if it was written out, means that I need to write down the base, multiplying it times itself 4 times. So x to the fourth looks like x times x times x times x. Then that is going to get multiplied times x to the third. So x to the third is x times x times x. So as you can see, this really becomes one big multiplication problem. X times x times x times x times x times x times x. So in order to simplify this, since I don't know what x is, it's kind of like combining like terms. How many x's do I now have that are being multiplied times each other? I have 1, 2, 3, 4, 5, 6, 7. So now I have 7 x's that are being multiplied times each other. So I could write that as x to the 7th power. Because x to the 7th power means I'm going to write down the base of x 7 times, multiplying it times itself, which is exactly what I just wrote when I wrote x to the 4th times x to the 3rd. So let's look at another one. Let's look at another one. I'll write it down. So if I have y to the 2nd times y to the 3rd, that's the same thing as y times y times y times y times y. So how many y's are being multiplied together? There's 1, 2, there's 3, 4, and 5. So I could write this as y to the 5th instead. So I haven't exactly stated what the product rule actually is, but I hope that you were able to pick up on it. If I have the exponent of 4 and the exponent on 3 on problem number 1, and I wrote it out, then I got the exponent of 7. So instead of making you write it out every single time, the easier way to state what the rule is if I take the exponent of 4 and the exponent of 3 and I added them, since they're the same base, 4 plus 3 is 7. So we're going to keep our base the same and add the exponents. Same thing in the second problem. The bases are both y, so I'm going to keep the base the same, and I'm going to add my exponents. So 2 plus 3 is going to equal y to the 5th, which is exactly what I got when I wrote it out in shorthand. So let me write out the rule so that you can get this written down. So if it has the same base, then we're going to add together the exponents and keep the base the same. Now, just like when we combined like terms in our equations unit, the only thing we can put together is if they have the same base. Basically, if they're like terms. So let's look at another problem. So in this problem, we have y cubed times c to the 4th times y to the 8th. Again, we have to find our like bases. So in this problem, I have y and another set of y's. So I'm going to rewrite this as y to the third times y to the eighth times c to the fourth. I can reorder it as long as I don't change anything. So then I'm going to use the product rule to combine y to the third times y to the eighth. So I'm going to keep the base the same, and I'm going to take 3 plus 8 to get 11. Then I'm going to bring down this c to the fourth into my final answer. So I have y to the 11th, c to the fourth. So far I've showed you examples with variables as the bases. But let's look at one that has a number as a base. So in both of these problems, the base is 1/4. So since they have the same base, we're going to keep our base the same, and we're going to add together our exponents. And here come your integer rules again. So I would highly advise that you double check your brain by punching things into your calculator. So I'm going to take -3 plus 15. And we should get, we should get 1/4 as our base and 12 as our exponent. So our answer is 1/4 to the 12th power. Go ahead and erase that. Let's look at another one. Now it's important to remember that each of our terms are separated with a multiplication symbol. So even though there's only one multiplication sign in this problem, there's actually more than that. Because in between this 4 and the x, and in between the 2 and the x, those are also being multiplied. So I'm going to rewrite this so that I don't get confused with what is with what. All right, so then I'm going to combine like bases. So I have 2 sets of x's. So I still have 4 times 2. And then I'm going to take the base of x, and I'm going to put 5 plus 2. So 5 plus 2 is going to simplify to 7. Now because I still have 2 whole numbers in here, and it's a multiplication problem, since I can evaluate 4 times 2, we have to go ahead and simplify that. So 4 times 2 is going to be 8. So our final answer is 8 times x to the 7th. I want you to try this next one on your own. So go ahead and pause the video and try this one on your own. All right, so that should have given you time to do it on your own. Hope you paused the video and tried it. So I'm going to rewrite this so that it is separated, each term with a multiplication sign. Now the first thing I notice, guys, is this c. This c doesn't have an exponent. If anything doesn't have an exponent, we need to give it an exponent. So just like before, anything that needs a placeholder, we're going to give it an exponent of 1. So now I can combine my like bases of c. So I'm going to have c, 3 plus 1 is 4. And I'm going to go ahead and combine my h's. So I have h, 4 plus 5. 4 plus 5 is 9. So my final answer is h to the 9th, c to the 4th. And then one last one. So I'm going to separate out each term. Alright, so I can put an exponent of 1 on that A. So I'm going to combine my A's. A3 plus 1 is going to be A to the 4th. It takes care of my A's. I like to cross them out as I go so I can see what I still have left. And then B's can go together. So if I take B2, 4 plus 2, I'm going to get B to the 6th. So then I still have a whole number of 3 and a whole number of negative 3. So I have to actually multiply these numbers together because that's what this sign is telling me to do. So 3 times negative 3 is a negative 9. Guys, remember that it's okay to have negative bases. It is not okay to have negative exponents. So again, the product rule is anything that has the same base, you're going to add the exponents together. If you need to go back and rewatch any part of that, feel free to rewind.